All right, today is October 13th, 2011. We're going to do example 3. This is still from lesson 2.6. Okay, that's the last lesson we're doing, and this is the last example before we start reviewing. So, it says Naveed is designing a can with a volume of 350 milliliters. What is the minimum surface area of the can? Determine the dimensions of a can with a minimum surface area. So, first of all, we need to figure out we know the volume is 350 milliliters. Let's get our two formulas down. One of the formulas we need to know is our volume formula, okay? So, volume of this can is actually equal to the area of the circle multiplied by the height of this object, okay? So we find the area of that top circle and multiplied by the height, we'll have the volume. So, area of a circle, anyone remember? Pi r squared, all right? So, this will be our r, the radius, and we're going to call this h, the height. So, the volume of this object is area, which is pi r squared, times the height, times h, okay? Now, since we know that the volume of this object is 350, we can substitute that in for the v. So our next part of the formula is 350 is equal to pi r squared times h. Now, this is very similar to our other question we did. We're going to have to use our trial and error to figure out which radius will give us a minimum surface area. So we're going to rearrange this equation to be equal to just h. So what that means is I'm going to move this bracket here to the other side of the equation. And since this is a bracket times a bracket, in order to do that, I have to divide both sides of the equation by pi r squared. What that's going to give us is 350 divided by pi r squared. These two will cancel each other out, pi r squared and pi r squared. So I'm left with just h on the other side. So we've set this equation equal to h. Now what I want you guys to do is to make a chart, and I'll tell you how large to. Okay, so we've made our chart. Our chart has a row for the radius. So we're going to be plugging in numbers for the radius. So we would start at 1, 2, 3, and we're going to go until we have minimized surface area. That's the questions asking us. The volumes are all going to be the same. 9, 10, 11, 12. We're going to try up to 12. What you'll notice is there will be a pattern. The pattern is it will start to decrease our surface area to a point, and then it will start to increase again. Okay? Now, if we continuously decrease even after a radius of 12, that means we need to extend this chart to try the number 13, 14. But we'll figure it out as we go along. Right now, I feel 12 should be large enough. The volume of our shapes are always going to be the same. The volume is always going to be 350. We've already put it into our formula, which we have down at the bottom. I'll number it. This is formula 1, okay? Yeah, just like the racing. So our volume is always going to be the same. Now, what we're going to be doing is we're going to be plugging in these values of r into this equation that we created to solve for a value of h. Once we get the value of h, we're going to use these to find surface area. And we have to minimize our surface area. So, in other words, I also need to make a surface area formula. So I'm going to go back to this page and we'll put it up here. This was our volume formula before. We have to figure out the surface area of this object, okay? Now, the surface area of this object is going to be the area of the top circle and the area of the bottom circle. All right, so like we were saying before, we need to find the surface area because we're trying to minimize surface area. So, surface area will be the area of the top circle, area of the bottom circle, and does anyone know what this shape is going to be here? It's going to be a rectangle. All right, so if you guys remember A long, long time ago in elementary school, you would have done nets. So the net of this shape will be a circle, another circle, just a rectangle, there it is, and it was all right, and a rectangle, okay? So I just want to show you what that would look like if you unraveled it a little. Oh, that was good. Okay, so we have to find the area of these three shapes. Now, to find the area of a circle, anyone remember? We just went through it.
Pi r squared.
Yes. So the area of this circle, area of a circle is pi r squared. Area of this circle, pi r squared. Now, this shape here is a rectangle. Area of a rectangle. Anyone remember? Yes, length times width. Very easy. But the only problem is we don't have a measurement. Well, we're looking for, we call this the height of the rectangle, okay? So I'm going to replace length with height times width. Because we were calling it h when I'd shown you the example before. So we'll call it h times our width. Now the width of this rectangle we don't have. We're going to have to solve it, okay? And the width of this rectangle is going to be equal to something on the circle. Does anyone know what it'll be equal to? Close. Getting there. What was that, James? Circumference. The circumference of this circle, so going all the way around this circle. Whoops, I forgot it does that. Going all the way around this circle is the same distance as this on the rectangle. Okay? So we need to find the surface area. The surface area of this object is going to be the area of two circles plus the area of a rectangle. Okay? And we're going to substitute in for these areas. Now, the circumference of this circle, we're going to talk about quickly to get us the length of this. Circumference of this circle, C is equal to pi 2r, or pi times the diameter. Okay? But since we're working with radius, I'm going to relate it to radius. We know that diameter is equal to 2 times the radius. So instead of using the formula C is equal to pi times d, I'm going to replace the d with pi 2r. Okay, so that's 2 times the radius. So what that's telling us is our width. I'm going to replace our width now with pi 2r. Those are all separate terms. Pi is a number, 2 is a number, and r is a number. Okay? So, since I have that as the area of our circle, now we're working with r's and h's because those are the only letters we had. The surface area of this object is 2. The area of a circle we've discovered was pi r squared plus the area of our rectangle. And in the book they've rearranged it a little. So I'm going to rearrange it after. We had h times pi 2r. You're going to notice in your book they've written it like this. 2 pi r squared plus 2 pi r h. Okay? I want you to recognize this is a term, this is a term, this is a term, this is a term, and a term. Those are all separate numbers. Okay? They're all being multiplied by each other. So I know the surface area is a bit confusing. Copy that down. You're going to use your formula sheet for your test, so make sure you know the surface area of a cylinder. All right, so we'll copy this and put it on the other page. Monday. Okay, so we have our formula. The first one we said we were going to do is we're going to plug in 1 for r. So when r is equal to 1, we get 350 divided by pi times 1 squared is equal to our height. Our height's going to be 350. 1 squared is 1, and 1 times 1 is pi. So we get 350 divided by pi. So the height for our first radius is 350 divided by pi equals 111.4. 111.4 is our height. Okay, so now we have a radius and a height. We're going to be plugging those into our surface area formula. There's our second formula that we use. Okay, so in this one we had a radius of 1 and a height of 111. Let's put equals. 111.4. So we plug them in. Surface area is equal to 2 pi 1 squared plus 2 and we go to solve this. So 1 squared is 1, so we're left with 2 times pi equals 6.2 plus 2 times pi again times 1 times 111.4, 699.9. We add the two together. We end up at 706. So that's a rather large surface area. So the surface area in this one is 706.1. What I'm going to have to do is repeat that process. When R is 2, plug it into the first formula, solve for H, then plug in R at 2, and whatever our H is into our surface area formula and solve. Did anyone find out what the minimal surface area? Okay, we're going to plug in when the radius is 2. So we're going to plug it into the formula we created above. We'll get 350 divided by pi times 2 squared. And that will give us our height. So 2 squared is 4. So we're going to end up with 350 pi times 4 is equal to our h. So we're going to try solving that now. 4 times pi equals 12.5. So 350 divided by 12.5. This will give us our new height. 350 divided by 12.5. 28 as our height. So our new height is 28. We're going to try plugging that into the formula for our surface area. So remember our surface area formula, SA was equal to 2 pi r squared plus 2 pi r h. Our radius was 2. Our height was 28 we just found. So we're going to plug those values in. We're going to end up with 2 pi 2 squared plus 2 pi 2 times 28. Let's solve these one at a time. So we know 2 squared is 4. So we're going to do 4 times pi. Whoa, that didn't work. 4 times pi times 2 gives us 25.1. So what I did there is I just did all of that in one step. Ended up as 25.1. And we're going to do the last part in one step. 2 times pi times 2 times 28. So 2 times pi times 2 times 28 equals 351.8. 351.8. When we add the two together, 376.9. So 376.9 is our surface area. That is much smaller than the surface area we had before. Romello, you said that the radius of 3 created a larger one? Okay, so we're going to jump ahead to a radius of 4 because we assume that's going to be our minimal surface area. We're going to plug it into our formula. 350 pi r squared equals height. So we're going to plug the number 4 in for the radius. We get pi times 4 squared will give us our new height. So 4 squared is 16. 350 divided by pi times 16 will give us our height. So we'll do this all in one step, since you've seen me do it once or twice now. 16 times pi is equal to 50.2. Divide 50.2 equals height. Our new height is 350 divided by 50.2, 6.9. So our new height is 6.9. So we go back to our formula at 4. This is what we're trying now. We got a height of 6.9. We're going to use that information. R equals 4 and height equals 6.9. And we're going to plug it into our surface area formula again, which was 2 pi r squared plus 2 pi r times h. When we plug it in, we get 2 pi times 4 squared plus 2 pi times 4 times 6.9. Try doing this all in one step. 4 squared is 16 times pi times 2, 105. 105. So that was that whole part done there. Plus, we'll do the next part. 2 times pi times 4 times 6.9. 173. Where is it? 0.4. When we add the two together, 273.9. Yes. Oh, if you're even more exact than myself, that's even better. Yeah, that's even better. Okay? I was rounding just to keep this quick. So, our surface area here was 273.9. And if you go through it all, this should end up being your lowest surface area. From there, the surface areas to start getting larger and larger again. So we would know that our radius of 4, height of 6.9 gives us a minimum surface area.